All right, our next talk is third talk of this morning session on Thursday, UGM2021. This is Lazlo Westerhof from Utrecht University, and he's going to talk about looking back, a retrospective, migrating Yoda from the PHP iRODS client to the Python iRODS client. Go for it, Lazlo.
Thank you, Terrell. Hi, everybody. As Terrell mentioned, I'm Lazlo Westerhof. I work at the Research and Data Management Services Department at Utrecht University. I work there as a software engineer and I'm the product manager of Yoda. And today I will be talking to you about how we are migrating Yoda from the PHP iRODS client, also known as the prods library, to the Python iRODS client. First of all, Utrecht University. Our university has a long history established in the 1600s with more than 7,000 staff members and 30,000 students. We are one of the largest universities in the Netherlands. A small introduction to Yoda. Yoda is a system for fair research data management during all stages of study. And with Yoda, researchers can safely work on data together with other researchers in groups in a research workspace. They can describe the data in a community-specific metadata scheme. And with a data deposit workflow, this work can be deposited into a vault space as a data package. This vault space will maintain the integrity of the data package, and from the vault space there's a publication workflow which makes it possible for the researcher to publish the data package in an easy way. Now, we deposit the data for integrity purposes. When a researcher has collected data, we want to deposit it as soon as possible. After it is deposited as a data package, it is read-only and you can only work on copies of it. We have a data deposit workflow where the researcher requests to deposit to the data manager, and then the data manager can approve it. The data manager is the steward of the vault. The deposit action requires that mandatory metadata has been completed, and researchers can complete the metadata using a metadata form in the web portal or upload a metadata JSON as long as it complies to the metadata scheme. Now this is the metadata scheme where the researchers fill in all their metadata for the data package. This is the same data package in our research environment, and it is submitted to be deposited into the vault space. The second workflow is a data publication workflow, and this workflow supports the researcher in publishing their data package in a fair way. And the data package can be submitted for publication by the researcher. The data manager approves that. The data manager has a different role here because we want to make sure the right license type is used on the data packages, or that not something is published that should not be published. Now, there's a lot of policy checking in this phase, but for the researcher, it's just a click on a button. When a data package is approved, the system will publish the data package, and for a published data package, a DOI is generated. A landing page is published and the metadata is registered at DataSite, and it's also available through an OAI PMH endpoint. So this is the same data package, but now deposited in the vault space. And when it's published, a landing page is generated, and that looks like this. Yoda Milestones. We have been developing Yoda for over more than 6 years now. In that time, we have developed a lot of functionality. We started in 2015 with a web portal for a specific project with iRODS 3.3. A year later, we added WebDAV support to our web portal with DevRODS, and we migrated to iRODS 4.0. In 2017, we added the data deposit and data publication workflows to Yoda, and then we made several improvements on how we handle metadata and upgraded to iRODS 4.1 and 4.2. In release 1.6, we changed our metadata storage format from XML to JSON and refactored a huge portion of our iRODS rules from the iRODS rule language to Python. So from the beginning in 2015, we had a web portal written in PHP and all the rules in the iRODS native rule language or microservices. With the refactor of our iRODS rules from the iRODS rule language to Python, we added the Yoda API. It's a REST API for Yoda. And with the addition of this REST API, it was a good time to refactor the web portal. So during this refactoring, we switched from the iRODS PHP client to the Python iRODS client. more about that further in this presentation. We also added support for OpenID Connect to our web portal, and we will also probably upgrade to iRODS 4.2.9 very soon. Yoda in numbers, to give you some perspective on the context we are working in, I have some statistics for you. At the moment, we have more than 5,800 users. Around 1,000 of these users are external, for example, from Groningen. Internal users are researchers and students from the Utrecht University, and everybody else are external users. The amount of storage used, at the moment we have more than 920 terabytes of research data managed by iRODS in 8 zones. So we are still on the terabyte scale, but we will enter the petabyte scale somewhere this year. So Yoda is built on iRODS. It deploys iRODS as its core component, customized with rules and microservices. And over the last couple of years, Yoda has grown into a very large system. It became a full-blown research data management system, with all the research data management functions built on top of iRODS, provided by several rules and services plugged in. So you can see iRODS with their data policies and data services on top, and consider the data integration and the configuration layer as the backend of Yoda. In the front end, Yoda has several ways for user interaction. We have a web portal for interaction through a web browser. We have a network disk available using DevRods, and our power users can use the I commands or other iRODS clients to interact. The web portal uses the Yoda API to communicate with the Yoda backend. So let's zoom in on the web portal. Users interact with the web portal, and the web portal will communicate this to the backend using the Yoda API. This API is defined in our iRODS rule set, and it's built as a REST API and exposes all functionality of Yoda. And with this API, we can build a very lean web portal, since all the business logic is in a rule set in the backend. This brings us much more flexible and easier maintainable code. Let's look at the code. So how do we expose a rule in a rule set as an API endpoint? Now, so let's take a look how we convert our iRODS rule, language rule, to an API function. And as an example, we have here a simple function that concatenates 2 strings. It has 2 input parameters, x and y, and 1 output parameter, foo. Written in Python, this rule will look like this. We have a list of rule arguments. From the list, we take the first 2 items and use them for the variables x and y, and we concatenate the 2 variables and store them in a rule argument list as the third item. This is great because we now have the function in Python, but by doing this to a lot of functions, we notice the boilerplate, also retrieving and returning the variables and result in the rule arguments list is not very Pythonic, and this made it difficult to interface from other Python functions. So we try to make it easier for ourselves. We added an API decorator that takes the JSON input and converts it to Python arguments, and it takes the Python return value and converts it to a JSON output. So it checks the required arguments, support digs, lists, and more, and it was a nice way for us to standardize error handling in a rule set. And it is really great because now we can write real Python functions and expose them as an API endpoint just by adding a decorator. If you want to know more about this and our Python rule set, you can also check out our presentation of last year where we introduced this. So back to the web portal. After the development of the API, the web portal situation looked like this. The web portal was developed in CodeIgniter, a PHP framework for building websites, and it communicated with the Yoda API using the iRODS PHP client. We decided to give our web portal an upgrade, and with the main reason to make it easier to change the user interface. So we switched from the PHP CodeIgniter framework to the Python Flask framework. Flask is a micro web framework. But since we switched from PHP to Python, we also needed to switch iRODS clients. So we switched from the prods library to the Python iRODS client. Now, besides easier changing of the user interface, there were some other reasons to switch to Python. So the iRODS PHP client is currently not actively maintained, and with the Python iRODS client, we can make use of the latest features of iRODS. The portal shrunk to a very thin layer around the backend, so that's really improved the maintainability. We can also use new features, for example, parallel transfers. We have more libraries and frameworks available and better tooling, for example, for test automation. To communicate with iRODS from Flask, we have written 2 modules. The first module is a connection manager module, and this manages the connections to iRODS. For every connected user, for every authenticated user, a Python iRODS client session is created. The second module we created is the API module, and this module handles API calls from the web portal and does all the JSON encoding and decoding for our API. And you see here a small snippet of the API module. This uses the Python iRODS client to create a rule. The first parameter of the rule is the iRODS session of the current authenticated user. The second is the body. It is a native rule language snippet calling a certain API function. And we add the parameters for this API function. And then we can execute this rule. And this will then trigger the function within the same name decorated with the API decorator in a rule set. So let's see what this interfacing looks like in code. So here we have the same API function from our rule set as in the previous examples. The concat API will receive a JSON input and output, which is automatically handled by the API decorator. In Flask, we can call the concat API function using the call function of our API module. We give as parameters the name of the API function we want to call and a dictionary with the arguments of the concat API. And this will return a dictionary in response, which we then can use in Flask. For JavaScript, we created the same functionality. And we also have a call function in the Yoda object, also accepts the name of the API function we want to call and the dictionary with the arguments of the concat API as parameters. This will also return a dictionary we can use in JavaScript. Now, with all these utilities, it became much easier for us to interact with the Yoda backend, and this really improved our front-end code. So we now only need a very really thin layer in Flask, and it's really easy to build new workflows on top of our existing API functionality. A good example of building new workflows on top of our existing API functionality is our data archive for geosciences project. In essence, it's the same workflow as the deposit workflow, but we want to create the most simple way possible for researchers at the university to deposit the data package. Use 3 simple steps: upload your data, add the metadata, and submit to create a data package in Yoda. So with Flask and with the Python iRODS client, this became really easy to create because we can reuse all the existing API functionality. Another nice addition to Yoda we could add with the help of the Python iRODS client is support for modern file web uploads. This adds a great way for our users to easily add files to their data package next to DAVRODS and the I commands. We use an existing library for modern file uploads called Flow.js. And the library gave us HTML file API support to upload folders and drag and drop. And with support for chunked uploads, we can also upload large files in a web portal. And resumable uploads makes it possible for our users to close their web browser and continue uploading sometime later. So the library took care of the front end, and the upload backend was really easy to implement with the Python iRODS client. So we made a lot of improvements using the Python iRODS client. Meanwhile, we ran into some small issues. The first one is more performance related. So after a rule is executed by the Python iRODS client, the session is cleaned up. So we need to reopen a session to iRODS after each rule execution. So after each API call. That gives a significant overhead where we need to execute multiple rules to build a web page. This is tracked as issue 190 in the Python iRODS client. The other issue is some weird character limit we are triggering. Both issues are already worked on by Dan, so we will have a solution very soon. And we will take a look at the latter during the troubleshooting session this Friday. Now, Yoda is free and open source. Everything is available on GitHub. Our deployment stuff can be found in the Yoda repository. We have a Yoda portal with the Flask portal. And the iRODS rule set is in the iRODS rules at UU repository. Thank you for listening. Does anybody have a question for me? I'm happy to answer them now. Or if you have a question later, you can hit me up on the UGM Slack or send me an email.
Very good. It's a lot of work. Thank you. And congratulations on your new being in charge. Very, very exciting. Do we have any questions? I think I see a couple of people typing some questions here. So this was a more than a year effort, I know, importing all this stuff. Yeah, and I think we've already found. I think we have a beat on the length limit thing that you found that you mentioned on the last slide.
Yeah.
It's the drama of typing. Here it comes. Typing slowly. So what happens to the PHP client? I think you might have been the last one using it.
Maastricht is still using it.
Okay.
If I'm correct.
That's right. I knew there were a couple GUIs a long time ago that have never been pulled forward. I have to get Maastricht to give a talk next year about the same thing. Did you think about using Fast API? This comes from Adil. Do you know Fast API?
I don't know Fast API.
Adil, if you want to, you can tell us about it. If you want to raise your hand, I can click on you. It's a Python REST API, it looks like. So Corey's
alternative for I see. Yeah, we were using Flask, so we use the tools inside there.
Okay. The ideal is now.
Yeah.
He can ask if he wants or talk to you about it.
Oh yeah.
Can we hear you?
Yes. Sorry. Yeah. I thought it was just quicker to talk than to type. I used to use Flask API in the past, and it's just that when integrating with some authentication protocols, I found that support within Flask was difficult, and the newer framework called Fast API was around, developed, which I think you will find it very easy to switch. And it also has some very nice features for, it supports, I can't remember the name of it now, like OpenSearch, not OpenSearch, sorry, the Swagger. So you will have some nice free things there. I mean, if you're interested.
We'll take a look at it. Sounds interesting. Thanks.
And then we've got a question from Corey. He says, I may have asked this last year, does the API decorator work with rule engine plugin continuation? Do they allow for small bits of code to do their thing and then get out of the way of other bits of code that might have the same name or allow the server to continue to do the work?
Yeah, I think that should work. I don't think we are doing that, but I think it should work. Right.
Yeah, you're probably not leaning on it yet. That became a requirement once we started to pull apart the policy composition stuff. We wanted things to be able to do a little bit of thing and then get out of the way and let something else that it doesn't have to coordinate with, handle its own bit of business. So that's something to definitely look into. And we've got, Martin Koonin from Maastricht says, we were using PHP until yesterday. They've also switched now to Python using Django. So we have an update. We'll make Martin talk about that next year. Maybe a lightning talk in the next 3 hours would be good. And then we've got a thumbs up for the API decorator. People like that. That's good. Anything else from anybody? Or last brilliant thoughts from Lazlo? I exit, very nice. All right, well, thank you so much, and we will see you, I hope, soon, before too long.
Yes, thanks for having me.
Bye-bye.